From the whisper of the wind to the roar of a rocket launch, sound fills our world. But what exactly is sound, and how does it travel from its source to our ears? Sound is a form of energy that travels as waves created by vibrations. Imagine a pebble dropped into a still pond. The pebble's impact creates ripples that spread out across the water's surface. Sound works in a similar way. When something vibrates, it causes the surrounding particles, whether they be molecules in the air, water, or even solid objects, to vibrate as well. These vibrations create waves of energy that travel outward from the source of the sound. Think of a sound wave as a line of people passing a beach ball along. Each person represents a particle, and the ball represents the energy of the sound. As the ball is passed from one person to the next, the individuals themselves don't travel far, but the energy represented by the ball travels the length of the line. These are called longitudinal waves, where the particles vibrate in the same direction as the wave travels. There's another type of wave called a transverse wave. Imagine holding one end of a jump rope and flicking your wrist up and down. The wave travels down the rope, but the rope itself moves up and down, perpendicular to the direction of the wave. Light, for example, travels in transverse waves. Sound travels at different speeds through different materials. Ever wonder why a train is audible through the tracks long before you hear it in the air? That's because sound travels much faster through solids like iron than it does through air. This is because the particles in a solid are packed much more tightly together. Think of it like this. If you whisper a secret to a friend standing close by, they'll hear you easily. But if you whisper the same secret across a crowded room, the sound will have to travel through more people and will be weaker and harder to hear. Section 4. A splash of sound. Sound also travels faster in water than in air, though not as fast as in solids. This is why whales can communicate with each other over vast distances in the ocean. The denser packing of particles in water compared to air allows sound waves to travel faster and farther. Imagine a message being passed along a line of swimmers in a pool versus a line of runners spread out across a field. The message will travel much faster and more efficiently through the closely spaced swimmers. Section 5. Sound takes flight. In the air, the speed of sound is affected by temperature. Sound travels faster in warmer air. Imagine air molecules as tiny bouncing balls. When the air is warmer, the balls bounce around more quickly, allowing sound waves to travel faster from one molecule to the next. Think of how much faster a rumor spreads through a group of excited children compared to a group of adults engaged in a calm conversation. The more energetic the particles, the faster the information, in this case sound, can travel.